Hello and welcome to Clear Water Quality. Today I'm going to show you how to create a precipitation diagram in order to show what a precipitant looks like and how it relates to the pH. So the example I'm going to use in this video is manganese, which is an important metal in drinking water systems because it can form a precipitant that is undesirable. Okay, so what we're going to do here is to create a log C pH diagram that we've done previously for weak acids, but here we're going to include um, a constituent that has a solid phase or that forms a precipitant. And then we'll be able to see how the precipitation and dissolution varies over different pH ranges. Okay, so getting started here, our example is manganese. And I have shown on this table um, 3 complexation reactions that occur from manganese with hydroxide. And I've also shown manganese hydroxide solid and its solubility reaction. So I have, for these 4 reactions, I have beta values for the first 3 reactions, and these were obtained from table 5.1 in the textbook by Snowiank and Jenkins, Water Chemistry. The last reaction is also shown on table 4 or 5.1, but it can also be found on table 6.1 in that textbook. Okay, so here we go. We are going to develop a log C pH diagram for manganese hydroxide. And in order to derive the lines that will go on that graph, we need to use these reactions and equilibrium constants. Okay, so the first one that we're going to look at is the reaction, the 4th reaction here, the dissolution of manganese hydroxide. And what I'm going to do is write out the equilibrium equation. Now before I get started I should mention that, let me switch my, okay, that we are dealing with a temperature of 25 degrees, so standard temperature, and also no ionic strength effects. Not for now, at least. Okay, so we're just keeping it simple in this example. I'm going to use reaction number 4 here and write out the equilibrium equation. So I have a KSO, it's the product of manganese and hydroxide squared. And then I'm going to rewrite this. So I have manganese is equal to KSO over hydroxide squared. Now I'm going to replace the hydroxide with hydrogen ion and the Kw, which I also know from the water equation. Didn't write the water equation, but it's just water dissociates into hydrogen hydroxide. So that looks like this. And our hydroxide is Kw over H+. Now you can see it would be really easy to make adjustments for temperature changes. All I would have to do is to adjust all my K values, and similarly I could make ionic strength effect corrections as well. Okay, so my hydroxide, now I'm going to have KSO times hydrogen squared over Kw squared. Still have manganese on this side. And now I'm going to take the log of both sides. So I have log manganese is equal to log KSO plus 2 log hydrogen minus 2 log Kw. And so if you're using a coding language like MATLAB or I prefer R software, you can go ahead and write code that would put this directly into your program. And that's what I've done over here on the right. I wrote an R code in order to plot this, and I just put this equation into my code. But if you're solving by hand, just go ahead and substitute in the values that are on the chart above. And so I have negative 12.8. And pH is the negative log of H plus, so this is going to be negative 2 pH plus 28, or 15.2 minus 2 pH. And this side doesn't change, so we still have the log of manganese. And I'm gonna write this. So that is my answer. That's the equation of a line. And so we can plot this, and what this line represents, it's the place where manganese, free manganese ion, is in equilibrium with manganese hydroxide solid. So that is the line that represents equilibrium. I've shown it over here on the right, and so I can label this. This is my manganese line. So over on the left side of the line, the system is undersaturated and won't form a precipitant, but on the right side, it can potentially form a precipitant. We're going to add some more lines in here and in the next video, so stay tuned. But if you're plotting this by hand, what you want to do is solve the equation at a couple of points. So for example, I had a pH of 10, log manganese is equal to negative 4.8, and at pH of 8, log manganese is equal to negative 0.8. So then you have 2 points, you can plot them on your diagram and then just join the points, and you have your first line on the precipitation diagram. Stay tuned for the next video because I'll show you how to draw the next line.